Now we'll review some concepts that you learned in geometry that tend to give a lot of students trouble at first. 30, 60, 90 triangles and 45, 45, 90 triangles. And the shortcuts are the ratios that are actually associated with those given triangles. Now, it's extremely important that you learn these ratios. They'll be a very big part of the foundation that you'll need to work off of as we move into the more advanced stages of trigonometry later in this unit. So as much as you probably did not like doing these in geometry, you need to get very, very comfortable with this given information. Now, you may or may not have been taught this, but the 30, 60, 90 triangle, if you look at this, this is actually taken from an equilateral triangle. And so if I took an equilateral triangle with 2 on each side, and I drew, and if you can remember, that's going to be 60 degrees all the way around. Now if I took this and I drew an altitude in a equilateral triangle, what I end up getting here is 30 degrees, and then I not only angle bisect that, but I also bisect this base, which will make this a 1. If I apply a Pythagorean theorem to this triangle in here, this 30, 60, 90 triangle, what you end up getting is the square root of 3 as the other leg. And that is where the 30, 60, 90 triangle comes from, and that's where the individual parts come from. Same thing with a 45, 45, 90 triangle. This actually comes from a square where we have 90-degree angles all the way around. And if I were to draw the diagonal across the square, it would break that 90-degree angle into 45-degree angles on both sides. Now if each side of this square were 1 all the way around, and we did the Pythagorean theorem on this new smaller triangle, we would end up getting the square root of 2 for this hypotenuse, and that's where this part, the parts of the 45, 45, 90 triangle come from. So this is an extremely important set of ratios and relationships that you need to have down cold. If we look here, we're going to look at this table. We have a table that we want you to find the sine of 30 degrees. And so we would look back at our given triangle, 30, 60, 90, and I would look at 30 degrees, and I could see that sine is opposite over hypotenuse, so that would be 1/2. And so I would fill this in with 1/2. And so what I want you to do at this point in time is I want you to fill in all of these boxes in this table for sine, cosine, tangent, cosecant, secant, and cotangent of each of these common angles from these special right triangles. So go ahead and do that at this time right now. Okay, if you notice, it asks us to leave these in simplest radical form. So some of your answers, you may have gotten something like 1 over the square root of 2, or something in that realm, and you would need to rationalize the denominator to put it in simplest radical form. And these are the answers that you should have gotten for the given tables. Now, we can do this type of stuff in our calculator as well. So let's take a look at how we would use our calculator. Now before we start, we have to make sure that our calculator is in degree mode. So let's take a quick look at our calculator. If you look at the home screen of your calculator, you see number 5 says settings. So if you hit settings, I want to change the settings, the general settings here. And if you look, it says that my angle, the second one says my angle is a radian measure. Well, we're going to be dealing with radian measures later on in this unit, but right now we want our actual calculator to be in degree mode because we're going to be dealing with degrees as a measurement of the given angles. So I'm going to hit that drop down, hit degree, and then what I'm going to ask you to do right now is to make that the default. And it says that you want to hit OK. And so now I'm going to go to my calculator. Now the quick and easiest way to test this, and you can see here on our first sample problem, on sample problem 2, it says evaluate the following using the table. Well, we know that the sine of 30 is going to equal to 1/2. That is going to be the quickest and easiest way for you to determine if your calculator is in degree mode or not. So let's see how we do that. If you look at your calculator keypad, underneath the control button is the trig button. And you see we have our 6 trig ratios. Now you can also see we have sine to the -1 power. That's an inverse, if you recall from our inverse matrices. So we'll come to that in lesson 2. Right now all we're worried about is sine of 30. So we're going to hit sine, and then we're going to hit 30. And it's in degrees, so it's going to read that as 1/2. Now, if this were in radian mode, it would come out to be something like 0.96 and a little bit of a longer decimal. So you would know that you're in the wrong mode at the particular type of problem that you're trying to work. So what we're going to do here is we know that this could also equal to 0.5, and that may be what your calculator had given you whenever you did that. So go ahead and do tangent of 45 and cosine of 60 according to the table up above, and then check with your calculator. Okay, so if you're looking at this, that should have been a pretty simple deal, and it'd give you a little introduction to using trig in your calculator. But take a look at this. This is an important relationship that you're going to come across a lot more later. Notice that the sine of 30 equals the cosine of 60, and there's a special relationship there that I want you to take note of. So play around with your calculator a little bit, test those trig functions, switch between degree mode and radian mode to see what the different types of answers that are given to you, and get a feel for that.